topic is going to be antibiotic sensitivity testing. So instead of using disinfectants and antiseptics, we're going to be using antibiotics. Antibiotic sensitivity testing using the disc diffusion technique of Kirby and Bauer. So it's often referred to as Kirby-Bauer antibiotic sensitivity testing. Okay, so I'll give you the details in a nutshell. What you're going to do is you're going to test 3 bacteria that are representatives of 3 common pathogens. So they're either actually represent the pathogen itself or a close relative of the pathogen. So we're going to have 2 gram-negatives, and the first one is good old E. coli, which is a wonderful opportunistic pathogen. And the second one is another opportunistic pathogen, Pseudomonas, and we're going to be using Pseudomonas fluorescens. Okay, also gram-negative bacterium. And then the last, the third bacterium we're going to be testing is Staphylococcus epidermidis, which also is an opportunistic pathogen and also is a close cousin of the king of bacterial tissue invaders, Staphylococcus aureus. Okay, so those are the 3 bacteria, and what I'll do is I'll have the cultures up front. Now what I did, folks, is I had the colleagues from Monday, Wednesday, they saved their stock cultures. They were supposed to put an X on the label so that you all would know that they'd been used. But then in addition, we'll add a few fresh. And the reason I did this is I know sometimes folks are just anxious to get going. So I just wanted to have some extra cultures so that you weren't getting frustrated waiting for new cultures. Okay, so we'll have our stock cultures up front. And just as you did for the disc diffusion for the antiseptics and disinfectants, you first need to do what to these stock cultures, you guys, before you swab on your plate? You're going to dilute them 1 to 10, right? Mm-hmm. So just as you did last week, for each of the bacteria, you'll get a new sterile serological pipette, and you'll use the pipette pumps to transfer 0.5 mils of the stock culture into 4.5 mils of fresh TS broth, okay, just like you did last week, okay, using aseptic technique. And then for each of the diluted cultures, you'll come up and get a fresh sterile cotton swab. And for each bacterium, you'll need 2 plates. Okay, so you need 2 plates of E. coli, 2 plates of Pseudomonas, 2 plates of Staph. So each team of 4 will need how many plates, you guys? 6. Good, okay. So after diluting your culture, you'll use the same technique that we showed you last time, that you're going to take your sterile swab, immerse it into the diluted culture, and you're going to use the swabbing in 3-direction technique to get a nice, beautiful lawn of bacteria, confluent growth. Okay, so you swab your plates first. Make sure they're well labeled with the name of the organism, the lab section, the date, and at least the name of 1 person in your team. After you've swabbed the plates, you don't have to put the names of the antibiotics on the bottom of the plate, you guys, because we're using commercially prepared antibiotic discs, and they have the initials of the antibiotics on the discs. So you don't have to label which antibiotic goes where. Okay? We have 6 antibiotics for you. So what we're going to try to do is just have you place the antibiotics in a roughly triangular shape. Remember, you don't want your discs right up next to the wall because it'll be very important on Thursday. We are going to be measuring the zones of inhibition. It becomes really important that we have good measurements. If you put the disc right up against the wall, it's going to be more difficult to measure the zone of inhibition. Okay, so you want to space them 3 antibiotic discs on the plates. The antibiotic disc stations, we've got 3 stations, 1 back here, 1 there, and 1 up here. Okay, so you'll take your plates over to the station, and the antibiotic discs are commercially prepared, and they're in these little plastic sleeves. Okay, now some of the sleeves we have metal holders for them, and this is very nice because one of the challenges in getting these discs out is just getting the disc pushed out over the edge of the plastic sleeve. So I'll show you the old, the more challenging way. Okay, so make sure you guys that you read the plastic sleeve for the name of the antibiotic. Okay, so this one is tetracycline. So what I'll do is I'll use my forceps and just try to push the disc till the edge of it is just over the plastic sleeve. Okay, and I'm just going to try to grab onto that disc. Okay, and I grab my disc, and then I want to place the disc on the surface of my swab plate. And the tricky thing here, you guys, is we're trying not to touch the tips of the forceps to the plate, because obviously we aren't using good aseptic technique here. We don't have Bunsen burners lit, but we're trying to avoid gross contamination of the tips of the forceps. Okay, so I open my plate, and I'm going to try to place the disc. I'll try to have the free edge hit first, and then I'll try to release the disc. The disc would cooperate. Okay, so it drops, and then I'll use the tips of my forceps and try to just gently apply pressure to the center of the disc, just to make sure that it's attached to the agar surface. Okay, and then I move on and place 2 other different antibiotics on my plate. Okay, applying a little bit of pressure, because when you're finished applying your discs, we are going to have you tape the plates together, tape the lids to the bottom. Okay, and we are going to have you incubate them inverted. Okay, so that's why we need to put a little bit of pressure on the disc so they don't fall off. Okay, so the antibiotics that we have are beta-lactams. We have penicillin and ampicillin. So these are the inhibitors of the bacterial transpeptidase. Penicillin usually can't cross through the outer membrane of most gram-negatives. It can't fit through the porins. So they chemically modified it to make ampicillin. Ampicillin can cross through the porins of many gram-negative bacteria. So ampicillin is broader spectrum, used against a wider variety of bacteria than penicillin is. Beta-lactamase will destroy both of these, however. Okay? And then our 70S prokaryotic ribosome inhibitors include erythromycin, tetracycline, and I'm so glad, you guys, we have this, clindamycin. And the reason I'm so glad we have clindamycin, this is an antibiotic that is associated with increasing people's risk for Clostridium difficile infections. So really be careful if you put your patients on clindamycin, because they later could develop those horrible Clostridium difficile infections. Yeah, so that's, okay. And then the final antibiotic disc you'll be placing is this combination of 2 antibiotics. One of the names for the combination is Bactrim, and this is a combination of trimethoprim, sulfamethoxazole. And you guys might vaguely remember that trimethoprim, sulfamethoxazole, these are sequential inhibitors of, anybody remember? And again, you guys, I know this is torturous, but this will help you for the final exam. You remember trimethoprim, sulfamethoxazole, they're sequential inhibitors of enzymes involved in blank synthesis in bacteria. Does folic acid ring a bell? Yeah. And remember, folic acid is a coenzyme in bacteria for nucleic acid synthesis. Right? So the trimethoprim knocks out one enzyme. The sulfamethoxazole knocks out a different enzyme in the metabolic pathway to make folic acid. So by inhibiting folic acid production, indirectly you're going to inhibit nucleic acid synthesis. So you're going to knock out DNA replication, you'll knock out transcription as well. So, yeah. So on the quiz, you guys, on Tuesday, it would be fair to ask you what is the mechanism by which these antibiotics work. So remember, beta-lactams, irreversible competitive inhibitors of bacterial transpeptidase. These 3 bind to the 70S bacterial or prokaryotic ribosome and inhibit translation or protein synthesis. And then the Bactrim, remember, sequential inhibitors of folic acid synthesis in bacteria. And again, you guys, that not only will help you for the quiz on Tuesday, it will help you on the final exam, because you know there's going to be a lot of antibiotics on the final exam, right? And, oh, and before I be quiet and let you guys actually work, I did want to let you guys know that this Friday, from 9 to 11, I'm going to try to put up as many of the posters as possible. And I know you guys are going, oh, is she crazy? We are so exhausted. We're so overwhelmed. But here's the thing, you guys. Many of these posters cover topics that will be on the final exam. And I thought it would just be an opportunity for those of you that can, and I know a lot of you can't, we'll have the posters up. If it like rings a bell and go, oh yeah, I really didn't get the nitrogen cycle, or I really didn't get the endosymbiotic theory, we'll have this poster there, and it can help us review that topic. So it could be maybe a more enjoyable way to start reviewing for some of the final exam topics. And of course, if you guys have any questions on any of the other material, like host defenses, we can definitely do that. Okay, so that will be this Friday from 9 to 11. Okay, I know, everybody's just like, oh, can you just pile it on deeper? Just, just give us some more information, okay? All right, guys, so we do want to remember safety is first. So lab coats, lab shoes, you need